Solve the following differential equation by using integrating factors. Assume x is greater than 0, use c as the constant. So there it is. How do we do it? Well, here's the steps. So step one, put the equation in the form, get y prime or do y dx alone, then the y stuff, the other side, no y stuff. So let's do that as step number one. So I'm going to grab this term and move it over. So I got x, y prime minus 4y equals x squared. Now remember, the y prime needs to be alone, so I'm going to have to divide through by x. So that'll cancel out, and so we'll get y prime minus, I'm going to write this as 4 over x times y just to see the x stuff in front, and then this is just x to the first. So there it is. We did step one. We got it into the right form. We got y prime alone, and then the y stuff, and then x. So we're on to step two. Step two, we're supposed to find the integrating factor, mu of x, which is e to the integral of p of x dx, where p of x is that x stuff that's next to y. So think, oh, okay. So this right here is the p of x. So the mu is e to the integral p of x dx. It's e to the integral. Now what's p of x? It's minus, in fact, let's just do it this way. It's minus 4 times 1 over x dx, right? It's minus 4 over x. That's minus 4 times 1 over x. That makes it easier to see the integral, right? So that'll be e to the minus 4 natural log of x, right? Because the integral 1 over x, natural log of x. And then, you know what we do? We take that minus 4 and we run it up there to the power zone. Remember that trick, natural logs? That's a property from pre-calculus of natural logs. Any number multiplying the front of a natural log can come up and become the power. So that would give us e to the natural log of x to the minus 4 power. Now, why would we want to do that? Because then we can cancel e and natural log, because then they're right up against each other, right? Before they were separated by a minus 4 or other things. But once the e and the natural log are right up against each other, they cancel. And so this just becomes x to the minus 4. So the mu integrating factor is x to the minus 4. Okay, so we got that. What do we do now? Step three, multiply the differential equation by that factor, all three terms. So I'm going to take that now. I'm going to bring down the differential equation, which is here, here, here. Bring those down. So y prime minus 4 over x, y equals x. So I'm going to multiply through by that integrating factor. So I'm going to go, okay, x to the minus 4 right there, and x to the minus 4 right there, and x to the minus 4 there. I multiply all three, boom, 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 by x to the minus 4. And can we simplify that a little bit? So not much going on here. This is just x to the minus 4. Kind of scribbly there. Y prime minus, now what happens here? This is x to the minus 4 times 4x to the minus 1. And this is x to the 1 times x to the minus 4, right? See what I did there? 4 over x is 4x to the minus 1, right? Now, why would I want to do that? Well, because then, see what I can do? I can add those powers. I'll put the 4 in the front. That's x to the minus 5, isn't it? Same thing here. Add those powers. This would be x to the minus 3. Okay? Now, what's so great about that? Let's go to step 4. Step 4 says the left side is the derivative of the product of the integrating factor mu of x and y. So write it as the derivative of those two things multiplied. So on step 4, I'm going to go, okay. The left side is really now the dx, it's derivative of those two things multiplied, meaning y, and what was our integrating factor mu? X to the minus 4. X to the minus, and that's equal to the other side. Is that true? You don't have to verify it, but it's nice to see it. Is the derivative of this stuff really go back to that stuff? Is that true? It does, because these are two things multiplied. You got to do the product rule. Derivative of the first one, which would be y prime times the second one unchanged, plus the first one unchanged times derivative of the second. What's the root of that? Minus 4 comes down. That's where you get the minus. Subtract 1 from the power, minus 5. Yeah, that's right. That's right. Nice little trick. And then step 5, integrate both sides of the differential equation. So now, step 5, we're gonna actually integrate. So I'm gonna come in here, I'm gonna go, yeah. Step 5, I'm gonna go integral, integral, uh, dx of y x to the minus 4. And this is x to the minus 3 dx. Okay. Now what happens here? These guys cancel because derivatives and integrals are the opposites. And so the y x to the times x to the minus 4 just drops down. That's why we did that. That's why we wrote the derivative on the left side, because then when we do the integral, integral and derivative cancel. Now the integral doesn't cancel over here because there's no derivative. It's just an integral. I got to do the integral. How do you do the integral? You know that. Add 1 to the power. That'll be minus 2 and then divide by that. So this will be minus a half x to the minus 2. And then don't forget, plus a constant whenever you do the integral of both sides. All right, we're almost there. Last step, we got to get, finishing this last step, we got to get y alone, right? Because in the end, that's what we want. We want y. What does y equal? So multiply through by x to the positive 4, because those will add. The x to the 0 is 1. That'll get y alone. Whatever you do to one side, to the other, x to the positive 4, x to the positive, getting scribbly. Right on through. So this will be minus a half. These powers add again. X to the 2, cx to the 4. Did we get it right? Minus a half x squared plus cx to the 4. There it is. And we got it.